Good morning, students. I hope everybody is doing okay out there. I am feeling all right. I do have a cough, however, so I just thought I'd like to keep my cough away from you this week. I'm hoping it's just a little cold and I'll get over it and be back next week. All right? Hopefully, it's not the bad stuff. All right, so let's go ahead and get started on our next subject here, which is we're going to be looking at our planets. So we've looked at stars, we've looked at our sun, and now we're going to look at our planets. We're going to start with the inner planets, also known as the terrestrial planets. That means that they're made up of hard, solid dirt. Okay, so terrestrial means Earth. And so we'll see next week when we talk about the ones known as gas giants. They're not made of solid stuff. All right. First of all, I do think it's good for you to know the order of the planets. All right, how many there are and what order they're in. Okay, so we have our sun. I will tell you right here that this picture of all the planets and our sun is not to scale. In other words, the sun, first of all, the sun isn't nearly big enough for this to be right. So the sun's much, much larger. But we wanted to have all the planets in order, so I'll show it to you. So one way to remember, you probably already know this, a way to remember the order of the planets is to have a little what's called a mnemonic. It helps us remember. So we look at our first letter of each of the planets and we say the words, "My very educated mother just served us nachos." All right, in the old days, we would have said, "My very educated mother just served us 9 pizzas," when we included Pluto. All right, as you know, Pluto has been given the boot as far as a planet, and next week we'll talk about why. There are certain criteria in order for it to be a planet, and there's one of them that Pluto does not satisfy, so bummer. All right, so we're going to be talking about these first 4 planets, Mercury, Venus, Earth, and Mars. And then those big ones, it shows there Jupiter after Mars, but truthfully, Jupiter's way far away from Mars. I mean, really, really far. This scale isn't even close to showing how far apart these planets really are. But we'll be looking at those fascinating gas giants, Jupiter, Saturn, Uranus, and Neptune next week. All right, so let's get started on our terrestrial planets. So the first one we'll be looking at is called Mercury. That little sign up in the right corner there, that is a insignia that is given. It's like a symbol that's for Mercury, okay? Mercury is named after the Roman god of messages, okay? So I'll show you him in just a minute. His name was Hermes in the Greeks and Mercury in the Romans, and Mercury was very fast, very fleet of foot. He had little wings on his feet, and he moved very fast. So the reason Mercury's named that is because Mercury goes around the sun very fast. And that's because Mercury's the closest planet to the sun. It's very close. All right, it is the smallest planet now that Pluto is out of the picture. It's only a little larger than our moon. So it's named after Mercury, the quick messenger of the Greek gods. I believe it's Roman, if I'm not mistaken, though. It travels quickly. Its year, so 1 year to go, its time to go all the way around the sun once, is only 88 days. How long does it take us to go around the sun once? Y'all know that, right? 365 days. We'll get to that here in a minute. But its orbit is quick, so it's going around the sun quickly, but it's also turning on its axis. That's called rotation. It rotates very slowly. For it to go from morning to the next morning is 59 of our days. All right, for us, it's only 24 hours to go around once, which is one of the reasons why Earth is so perfectly suited for human life. There's so many reasons, and we'll get to it in just a minute here. But so what that means is that for half of that 59 days, so 30 days, part of the planet is facing away from the sun, so it gets very, very cold, and the other half is facing toward the sun, so it gets very, very, very hot. There's no atmosphere, so there's nothing to protect it from any kind of solar radiation or heat and cold and that kind of thing. So very inhospitable. I will tell you, it's kind of hard to study Mercury because it's so close to the sun that when we put our telescopes over there, the sun's brightness behind it just blinds us. So we really can't see it very well. So honestly, we haven't been able to study it very well. And I'll be telling you some stuff today that scientists have come up with that in reality, we're not really that clear about. So here's Mercury. There he is. Notice he's got his wings on his sandals and his helmet. And what he would do is he would take messages for the gods. He's not real, right? But this is what we named the planet after. And then he would go deliver them very quickly. So he moved quickly. That's why we gave him that name to the planet that's closest to the sun. Okay, let's watch a little video about it, give you a little more information.
Mercury, once believed to be two separate stars, it is the smallest planet in our solar system, barely larger than the moon. Surface temperatures can go from a scorching 800 degrees Fahrenheit to a frigid 300 degrees below zero. 48 million miles from the Earth, Mercury is dangerously close to the Sun, making it possibly the most difficult of the 8 planets to reach. So will we ever unravel the mysteries of this tiny world? Welcome to Space School. Observations of Mercury date back 3,400 years to the writings of the ancient Assyrians. The Romans later named the planet Mercury, the messenger among the gods, and protector of travelers. An appropriate moniker, Mercury races across the sky, orbiting the sun every 88 days, far faster than any other planet. Despite its short year, a single day on Mercury equals almost 59 Earth days. Mercury is the smallest of the 4 terrestrial planets, even smaller than Ganymede and Titan, moons of Saturn and Jupiter. Yet Mercury is extremely dense, the second densest planet in the solar system after Earth. The planet is thought to be more than 2/3 metallic and just 1/3 silicate, or rock. Its molten core has a higher iron content than any other major planet in the solar system, and the core makes up a larger portion of its mass, 42%. Mercury's landscape is similar to our moon, with extensive mare, or plains, and marked by deep craters, scarring left behind after millions of years of bombardment by comets and other celestial debris. With an atmosphere so weak it's barely detectable, comets and other space debris headed for Mercury don't burn up on their way down as they do on Earth. In fact, they're barely slowed at all, so any meteor or asteroid pulled into the planet's orbit will eventually smash into this rocky world. One crater, the Chloris Basin, is 800 miles in diameter, making it one of the largest impact sites in the solar system. It is so large, in fact, that scientists believe this collision actually reshaped the topography on the opposite side of the planet. Like the moon, Mercury has no plate tectonics and is geologically inactive. Mercury is so small and its gravity so weak that it is unable to hold on to an atmosphere for any significant length of time. Unlike Earth and the huge gas giants of the outer solar system, Mercury's lack of an atmosphere means it essentially has no weather, no gases to create winds or clouds to blow across the horizon. And being 2/3 closer to the sun as Earth means sunlight on Mercury is 6.5 times as intense. The sunlight is so intense, in fact, that some astronomers believe it has actually eroded the surface of the planet for billions of years. But despite this intense heat, ice may actually be found in the deep craters at the planet's north and south poles. Radar data has shown that water, permanently frozen, may exist in areas shaded from the sun. Even with water found on Mercury, without an atmosphere, life is all but impossible. Mercury, in galactic terms, is very close to Earth. Surprisingly little is known about this planet. Orbiting so close to the sun makes it extremely difficult to study. Worse, reaching Mercury means fighting the pull of the sun's gravity. In fact, to send a spaceship there requires as much rocket fuel as sending a probe in the other direction as far as the very edge of the solar system. Despite these difficulties, in 1974, the American Mariner 10 reached Mercury. This spacecraft made 3 close approaches, one which even took it within 200 miles of the planet's rocky terrain. The probe succeeded in photographing almost half of the planet's surface. The next mission to Mercury, the NASA Messenger, made its first flyby in January 2008. This probe, using high-resolution cameras that did not even exist in the 1970s, is mapping areas of the planet never before seen. Messenger will continue making flybys of Mercury until 2011. After 2011, the spacecraft will enter a permanent orbit with Mercury and continue to send back valuable data for years to come. The determination of NASA and the world of astronomy may mean that soon the great mysteries of our tiny neighbor, the planet named for the messenger of the Roman gods, will finally be revealed to science. This is Space School, signing off. Class dismissed.
All right, there we go. This is, I believe, an actual photograph from that mariner that took some pictures of it right there. And you can see lots and lots of craters on there. So that explained it to you, since there's no atmosphere. There's nothing to keep them from hitting the surface, right? So they just make these giant holes in there. Like I said, it is difficult to study this. What we do know about it is it's the smallest planet and it's closest to the sun. And I have a little bit of data here that someone in NASA believes they've figured out. So we know how big it is, all right? So a diameter of 3,032 miles, so 2/5 of Earth diameter. It has, we know how fast it rotates, right? And we know how fast it goes around. So 88 days to go around, 59 Earth days to turn once. It says here there's a thin atmosphere, but I doubt that's true. I don't know how they would know that. Furthermore, they say it has a metal core. We don't even know what the core of the Earth is. So for us to say that we know what the core of Mercury is kind of silly. Although there are certain things that might indicate, if we've done found some data about magnetism, things like this, that might indicate that maybe it has a metal core. We don't know. Here we see down here at the bottom the picture of the surface and how it compares to our moon, about the same size as our moon, a little larger. And then if you see that person jumping up right there, we do know because of its size how much gravitational pull it has. So if on the Earth I can jump up and make a dunk into a 10-foot basketball goal, which I cannot, in Mercury I could jump really high because it's not holding me down on the surface very tightly, right? So the gravitational pull is much less. So anyway, for what it's worth, this is what some of the ideas of what it might be like up there, but once again, we really don't know that much about Mercury. All right, moving on to Venus, you'll see the little insignia right up there to the right is the sign for Venus. It's also the biological sign for female, and so that is because we think of Venus as a beautiful woman, and the reason Venus was the goddess of love. And we think that because I'll show you some pictures. It is very beautiful, but very deceiving because it's not beautiful when you get in. All right, it's the second planet from the sun. It's often called Earth's twin because they're about the same size. It's covered with poisonous clouds that keep the planet very hot. So it's got lots of atmosphere, a thick atmosphere of CO2 and some sulfuric acid in there. And because of that, since it's got thick clouds on it, we haven't been able to see through the clouds to see the surface of the planet from outside of the planet. So when we send a probe around Venus, it takes pictures of it. All we really see are giant clouds around it. So there's a lot of pressure because we have this atmosphere. So we'll see a picture that a space robot landed on the surface and took only 2 pictures. While the atmosphere is highly acidic and poisonous, it reflects the sun, and so it looks beautiful. So that's why it's named after the Greek god of beauty, I believe, if I'm not mistaken. I keep saying Greek, but I think it's Roman. Is that right? I think Venus is the Roman god. It can be easily seen from Earth. It's sometimes called the morning star or the evening star. So when you look up into the sky at night and you see that, starlight, star bright, the first star I see tonight, I wish I might have the wish I wish tonight. Have you ever done that? Typically that first star that's out before it's terribly dark is probably Venus. Okay, it's very bright. If you look at it closely, you can see it seems large, and it also doesn't twinkle as much, right? Okay, it spins the opposite direction. We call that retrograde. So where the Earth is spinning one way and all the other planets are as well, it spins backwards. Doesn't necessarily mean anything. It's just interesting to note there. Their year is 225 days long. It takes 225 days to go around the sun. It takes us 365, right? So it's a little closer in there. And the length of its day, y'all check this with your book. It says 117 days is the length of a day. All right. So, but previously on my previous slide, I had a big number for Mercury that was wrong. So we'll check that one and see. Here's a picture of it. Look how beautiful it is. See, that's why people looked at it and said, oh, it's beautiful, like a beautiful woman, right? But deadly. Yikes. Here's what we think we know about it. This will tell us how long a day is, I think. All right. like it says here, it's often visible from the Earth, right? The evening star. It's the twin. It has that thick atmosphere, carbon dioxide, nitrogen, and trace gases, including sulfuric acid. It might have a metal core, not exactly sure. Since it is about the same size as Earth, the gravitational pull is very, very similar. You can see right there, it's just tiny, tiny bit smaller than the Earth. And this slide doesn't tell us how long the day is, so that's still a mystery to me. Okay, I did look it up. It is correct, 117 days or so as one day. So it spins once again slowly. All right, so now this is a fabulous picture right here. It was on the previous slide, but I wanted to show it bigger to you right here. This is a Russian probe that wanted to land on the surface of Venus to get through those clouds to see what the ground looked like. It took 2 pictures, 2 photographs, and then it was crushed completely. I'm talking about the probe with its camera, crushed. What was it crushed by? All that pressure of the atmosphere of Venus just crushed it. And so, but we did get these couple of pictures. Here's the best one. And you can see that the surface looks very uninviting, doesn't it? It's very dry. Remember that horrible atmosphere that is like poisonous gases? Yikes. All right, so these are apparently some blanks you can fill in your book if you find the right page here. Venus is surrounded by clouds, and it's the hottest planet. Now, the reason it's hotter than Mercury is because those clouds are like a greenhouse or like a blanket. So the sun's rays actually get trapped inside the planet, inside its clouds. It's the same thing that happens on the Earth, right? But it's good for us. It helps keep our planet a little bit warm enough to live here. All right, moving on to our Earth now. There is the symbol for the Earth, the circle with the little cross in it. It's the 3rd planet from the sun. It's the only planet known for sure to have water, and that water is in all 3 forms: solid, like ice; liquid, like water; and gas, which is the clouds in the sky, right? The atmosphere has a lot of water in it. Our atmosphere is perfectly suited to life. It has the right mix of oxygen. It's not too much oxygen. It's just perfect. It's got other gases in there that help plants grow and things like that, like nitrogen, for instance. We know that our Earth year is 365 and 1/4 days. That 1/4 causes us to have a leap year every 4 years or so. Our day is 24 hours long. You knew that. It allows just for the perfect amount of heating and cooling. So how about that? All these things that are just perfect for human life. What a happy accident, right? Well, you know for sure what I believe is that it was designed for humans to live here. Okay, there are so many things about the Earth, the distance from the sun, our atmosphere, all these things that are perfectly suited to life on Earth. There's a lot of water on our planet. About 74% of our planet is covered with water, mostly oceans. And from outer space, we'll see a picture, and some people call it the big blue marble. So this is a lovely picture from outer space. You can see we're looking right down at Texas right there. You see Florida to the right a little bit, and then Texas to the left, and then down Mexico. And you can see some clouds, right? Some clouds. It looks like a clear day in Texas on this particular day that this picture was taken. But some beautiful pictures showing the lovely blue oceans and the land that's there as well. All right, like I said, we live on the Earth, and we're not absolutely positive about what's in the middle of our Earth. Here's what we think. We have really great evidence, of course, because we can study the Earth more easily since we live here. We believe that the inner core is probably solid metal. And one reason we believe that is because we have a magnetic field on the Earth that's very, very important to our survival here. And metal is, of course, a good magnet. We believe it's solid because it's under a whole lot of pressure. And typically, if you put something under a lot of pressure, it'll turn it into a solid. Then we have our outer core we think is a liquid metal. So think about melted, coins or something, melted metal. And that is surrounding the inner core of solid. Then we have this thing called the mantle. Now, the mantle is probably rock, but when it gets toward the surface here, you see that word up there that says asthenosphere? All right, the asthenosphere is a part of the mantle that starts to liquefy, okay? And then it says above that the rigid mantle. So the asthenosphere is probably a liquefied rock, and we've actually seen it. When you look at volcanoes and you see the the magma rise from underneath the earth and come out of a volcano, and it makes lava, and it's that flowing red stuff, then we have what we believe is our liquid portion of the mantle. They keep changing their mind specifically about which part is rigid, which part is solid, which part is liquid. And so I think right now that the consensus is that the asthenosphere is the liquid rock portion of the mantle, which is made up of magma, and that below it is very much stiffer. It's not quite as liquid, it's much more solid. So I think that's where we are now. Then, of course, on the top we have the crust, which is where we live. And it turns out the thinnest parts of the crust are under the ocean, and the ocean can be pretty deep, you know. So for us to dig through the crust, it's been very difficult. There are some really soft spots around, some hot spots they call them. Those are volcanic areas when islands can form and things like that. But we have successfully drilled down through the crust, but we've only got down 7 miles. And that was in Russia. And when we got down to that 7 miles, it became really difficult to have a tool that would keep reaching down beyond 7 miles. And things started to get hot down there, okay, because of the pressure. So we stopped the digging process. When I was growing up, they had only dug down a mile. So it's now at 7 miles. So we've never dug through the crust into the mantle, ever. So that's why we have to base all of our data off of studies that are indirect. For instance, if there's an earthquake, then that earthquake will send out waves. And then we can look at the way the waves react as they go through the earth, and we can tell a little something about the way the waves act. If they're going through a solid or if they're going through a liquid, they act a little differently. It gets really complex there. Okay, the Earth is the only planet with the atmosphere and liquid water that allows for life. Okay, we have not found it anywhere else. They're so hopeful about Mars having water on it, and even the idea that Mercury has some frozen water in those deep, craters. I don't know. That's kind of wishful thinking, I think. Okay, what about our moon? So we have a moon going around us, just one moon. It orbits the Earth every 28 days. We call that a lunar month. Okay, so that's how we name our months, is based on the moon going around us. And we've been there, right? We've traveled to the moon. Men have stepped foot on the moon. And so we know quite a bit about its surface because of that, because we've been there. We've taken lots of pictures and that kind of thing. Now, we're going to be talking about the phases of the moon. Some of you have probably covered that before, but I find it fascinating to watch the moon. I love looking at the moon at night. We're going to see about those phases that it goes through in relationship to the sun. It does have a gravitational pull, and because of that, its gravity will pull on the Earth. It turns out that we need the moon. So there have been times in the past where people said, oh, let's blow up the moon. I don't know why they'd want to do that. It's a lovely thing to have in the night sky. But the idea is we need it to pull on the water on our planet, making the tides in the ocean. So because we have tides in the ocean, we have the water of the ocean always moving. And since it's moving around, it is stirring the water up. And when it stirs the water up, that helps to distribute the life that's in there. So it really does help. And our moon is just, even more than that, our moon is important to us to have there, the gravity part of it and the light part of it. It turns out that it's kind of funny. If we didn't have it, our gravity would treat it differently. For instance, we might get more meteorites and things. Right now we have meteorites hitting the moon instead of hitting us, right? And of course it creates craters and things like that on it. We'll talk next week also about the fact that the gravitational pull of Jupiter far away is important to keep the Earth safe too. So even if our solar system were changed a little bit, it would cause, a change in our life, the way we live it here on the Earth. So once again, we see evidence for a beautiful creator who has put things just perfectly on this Earth for us to live here. Thank you, God. All right, here's a nice picture of the full moon. This is taken really close up. You can see those bright parts are higher up. You can see the almost star kind of shape on there is where they've had a meteorite hit. The darker areas, the round circles there, those are called mare, or oceans, if you will. There's no water there, but they're kind of flat and indented. And so there may have been a big impact at one point there or something like that. You may have noticed if you've ever looked at a full moon that it looks, when it's full, it looks the same all the time. And that's because that's the only side that actually is, that we actually see from the Earth's surface. The way that it rotates on its axis keeps it facing this direction toward us all the time. And when the only time the dark side of the moon, the part we don't see, is visible is when it is in a new moon state and we can't see it at all. I don't know if that makes any sense to you. We are going to watch a little video here about the phases. So here is to the right the sun, and you can see the moon going around the Earth, and as we're looking at it, you can see the sun shines on it a little differently. Okay? And so when you can see this new moon right there, we don't see it at all. And that's the time that the other side of the moon's surface is toward us, and we can never see the dark side of the moon. That's why it's called the dark side of the moon. We did get a picture of it, so we know what it looks like now, because we took some astronauts up there who took pictures of it. Okay, here comes a video that's going to explain the phases of the moon.
If you ever look up at the moon in the night sky, say before you go to bed, you've probably noticed that as the days and weeks go by, the moon looks like it's changing shape. Some nights, it's a little sliver, and some nights, a few weeks later, it's a big bright circle. Well, the moon doesn't actually change shape, but our view of it does. Why? Well, the moon, just like the Earth, has a day side and a night side. A part that's facing the sun and a part that's not. So when we see a little sliver of bright moon, we're seeing a little part of the moon that's facing the sun, while the rest of the side that's facing us is dark. And the size and the shape of that sliver of lit up moon changes because the moon orbits or moves around Earth. It takes the moon about 1 month to make one full orbit around the Earth. And as it moves around our planet, the daytime side of the moon, the side that's lit up from the sun, is facing in different directions as we see it from Earth. This means that every night we get a slightly different view of the moon. And during its month-long trip in orbit around the Earth, the bright part of the moon appears to grow and then shrink from right to left. The different shapes that we see of the lit up part of the moon are called phases. And there are 8 phases of the moon. The first phase is the new moon. This is when the nighttime side of the moon, the side that's facing away from the sun, is what we can see from Earth. The moon is still up there, but because it's the dark side that's facing us, we can't see it during the new moon phase. The next phase is called the crescent phase. This is when the moon looks like a little sliver, kind of like the tip of your fingernail. After the crescent comes the quarter moon. This is when the moon looks like a half circle. And the next phase is called gibbous. A gibbous moon is when it's missing just a little sliver of light and it's almost full. And that's what's next. The moon is at its brightest at the full moon. That's when the fully lit up side of the moon is facing us, so we see a big bright circle. But we're only halfway through our phases. After the full moon, the lit up part of the moon appears to shrink. And just like how it grew from right to left, the sunny side of the moon will shrink from right to left too. So after the moon is full, it starts to shrink back down to a gibbous moon. But this time, you'll notice that the left side is shining bright instead of the right. After the gibbous phase, the moon will look like half a circle when it reaches the quarter moon phase again. And then after a few days, it shrinks down to a little sliver again, the second crescent moon. After that, the tiny sliver shrinks all the way down until the lit up side of the moon can't be seen at all. Now the moon is a new moon again. It's the same old moon, but it's gone through a month-long cycle of phases, and it's ready to start all over. Like I said, it takes a month for the moon to go through all 8 phases. In fact, our word month comes from the word moon, because it takes a month for the moon to go from new moon through all of its phases and back to the new moon again. So tonight, before you go to bed, take a look out the window. If the sky is clear, can you see the moon? If you can, what phase is it in? Is it the bright part of the right side or the left side? As the days go by, keep an eye on it and watch how the moon looks like it's changing shape. You can even make drawings to keep track of how it changes from day to day. Now you know that the moon doesn't really change shape. We just see different amounts of the sunny side of the moon as it makes its monthly trip around the Earth.
Okay, she's very enthusiastic. But I like the explanation. It's very good. So I love this picture. These are photographs of the different phases. And so notice how it's filling up one side and then goes to the other side, right? So it's on the right side till it gets full. Then it's on the left side till it's dark again. All right, so our full moon right in the middle. Some people think that they look at the full moon and they can see a person's face. We call that the man in the moon. I don't know if you feel that way about it. Sometimes when it's farther away, it does kind of look like that. All right, here they are. We have our new moon. Then we have our young waxing crescent. Waxing means it's growing. Okay, so waxing crescent, waxing quarter, waxing gibbous full, and then waning. So waning means it's getting smaller. Okay, so waning gibbous, waning quarter, waning crescent, and old. So 1, 2, 3, 4, 5, 6, 7, 8, 9. They have 10. And so look, it says new moon and old moon. Okay, so those were, some of those were left out of the, the 8 phases that were talked about in the video. I like this picture. Okay, this takes us through. Here we are at full. And now we're going to be waning. I think that's just beautiful. And then we can't see the other side of the moon. Okay, now it's going to start over. So that's pretty cool right there. I enjoy that. Like in the video, if you get a chance to go out and check out the moon, I think maybe it might be cloudy tonight, but it would be good to go take a look at it. Okay, so speaking of the moon, have you heard of an eclipse? Probably you have, okay? So what is an eclipse? When the moon gets between the sun and the earth, the light from the sun can be blocked for a short time. That's called a solar eclipse. So it is the moon blocking the light from the sun. Now, the moon isn't even close to as big as the sun, but it's a lot closer to the earth than the sun is. So it actually just kind of fits right over it. It looks like it fits right over it in the night sky. So when the shadow of the earth obscures the full moon, that's known as a lunar eclipse. So that's only when it's full. Okay, so a solar eclipse where the moon is between the earth and the sun only happens during a new moon, and the lunar eclipse only happens during a full moon. All right, so when the moon is in those other phases over there, it can't have an eclipse over there. You'll see why here. All right, so here we go. We have the sun. Now notice our moon is between the earth and the sun, right between it, and that is called the new moon. And if it gets in such a way that it blocks that little bit of sun from the earth, it's on a certain plane, you know, so kind of flat against the plane of the earth there, then you can see that little dark triangle here that hits a spot on the earth. I don't know if y'all remember a couple of years ago when we had a solar eclipse and it was visible from Texas. Y'all would have been pretty young, I guess, but I remember going out. I had a special mask thing to look at it with, and you could see almost a full eclipse of the sun, which was pretty cool. And also I was able to hold up something that had holes in it, and the holes would project the eclipse of the sun on the ground, you know, so it was very interesting. It sort of got dim in the day and that kind of thing. So that happens during a new moon, and notice that the little point of that triangle, of the dark triangle, is very small. So when a solar eclipse happens, it's only visible for a small portion of the people on our planet. And so that particular one that happened, I think 3 or 4 years ago, it was nice because it came right across the United States. Now, Texas was a little bit to the south of where there was a full eclipse, but a good portion of our country was able to see a full eclipse during that one. There are some people that chase eclipses. They like to go where one is, so they'll go to different countries and things like that. You can predict them because we know when the moon is going to be in its new phase, and furthermore, we know where in the sky it's going to be that will make an eclipse. All right, so this is what it looks like when it starts to cover up the sun. Now, I need you to understand that this picture was taken with a very, very advanced filter. Never, and we know this, remember I told you last time, never look at the sun, right? Even during an eclipse. We learned that in that video we watched last week. All right, but you can see that moon, the disk of the moon is coming in and eating away at the sun. When it covers it completely, it doesn't 100% cover it up, so we see that little edge around the sun. That is called corona. Now, corona means crown, and I know this virus we're dealing with called the coronavirus. I don't know why it's called that. Okay, but here you can see it looks like a crown around that. Now, scientists love to study the sun at this time. Notice how we can see those little red flares and stuff coming on the edges. Because we have so much trouble looking at the sun because it's so bright, you know, I'm talking about scientists looking with, you know, filters and things. when this happens, it really dims it, and the scientists can get these really great pictures like this one and do a lot more study of the surface of the sun. It blots out the majority of the light so we can see a little more what the surface looks like. Now, a lunar eclipse, this is going to happen differently. This is the shadow of the Earth shining on the moon. All right, the moon must be full. Notice it's behind the Earth. How else is it going to have a shadow on it, right? So here it is. Notice it's called the umbra, is that kind of brown color coming through there, is pretty large. So typically when there is a lunar eclipse, everybody gets to see it. The whole half of the Earth that it's nighttime gets to see it. Okay, and so different than the solar eclipse, which is only a pinpoint of visibility. This one can be seen by everybody. Now it does go by much slower. Also, the solar eclipse happens quickly. It comes, it covers up the moon, covers up the sun, and the moon moves away pretty quickly, over just a few minutes. But this one actually can last over an hour or so. For the Earth to spin around, for the moon to come out of the umbra into the penumbra, and then around the rest of the Earth right there. Okay, this is what the moon looks like when it's being eclipsed. You can see at the top it's full, and you can see it's starting to be eaten away by the darkness. Interestingly, once it's completely covered, it actually ends up with this red kind of hue to it. Some people call that the blood moon. And that has to do with the light reflecting in such a way that it makes it look a little bit red like that. So it doesn't go completely dark. It does kind of look like that reddish, sometimes more than others. So only some of them tend to be called a blood moon. All right, moving on to Mars. You can see the insignia right there, the symbol for it. That is also the biological symbol for male, and that is because Mars represents the Roman god of war. Okay, so we have Venus and Mars, right? And here we go. It's the fourth planet from the sun. It's about half the size of the Earth, so small. It's covered with red dust, so we call it the red planet. Because the dust is red, we have an idea that it's been got iron in it that's been oxidized by some sort of oxygen, meaning there might be we know there's a very small atmosphere with some oxygen in there. It's named after the angry, I believe, Roman god of war. Because it's red, it's like angry, right? We know a lot about it because we have sent several probes to study it. So our video on Mercury said it was hard to send stuff to Mercury. It's easy to send stuff to Mars. Well, when I say easy, relatively easy. We've sent several probes up there. None of the probes have ever brought anything from Mars back, ever. So all the studying's been done remotely, and we use the data that gets sent back to the Earth to make some decisions about the surface of Mars. Okay, it has the largest mountain in the solar system. It's called Olympus Mons. I'll show you a picture of it in a minute. It's larger than our largest mountain on the Earth. Keep in mind, of course, there are no oceans or anything on Mars, so it's just sticking up. It has two moons, Phobos and Deimos, which are not very round. It's kind of strange. 1 year is 687 days, so it takes that long to go all the way around the sun, so twice as long as Earth. But I think the day, yeah, look, 24 and a half hours. The day is similar to ours, right? So a lot of people have these hopes about Mars being the second Earth. Well, we'll see a video in a second. Yikes, okay. Here's a picture of it. This is a photograph that has been taken by one of our probes that have been sent up there. It looks very inhospitable. We see all that red. We see lots of craters. There is a very thin atmosphere. And notice at the top of that picture, it's a little bit out of view there. There's something white up there. We think there's something frozen up there, and it's possibly frozen water. We don't know, but it's possible that it's frozen water. It might be frozen something else, frozen ammonia or something. We're going to try to check that out. Also, lately we have had scientists saying that we know that there's water under the surface of the planet. So under the surface there's water. I have no idea how they know that. Okay, so sometimes I think that the scientists can have a little wishful thinking and think that. But they do have some data, apparently, to show that there might be water under the surface. We have studied this, of course, a lot, and there was a famous scientist, a famous astronomer who studied this, and he believed that there were little people on there with making canals because they were changing. He could see from his telescope here on the Earth. Well, it turned out that that was just wind that was blowing, and there, as far as we know, there are no Martians, no people living on the Earth, on Mars. We're still looking to see if there's any evidence of any kind of life, bacteria, something like that living down in the soil. We have found nothing so far. Scientists are really hopeful to find living things, and I think one of the reasons is they want the Earth not to be special. So I feel like I'd rather not that we not find any life on Mars. Here's what the surface looks like. It's very inhospitable, very dusty. We're going to see in a video in a second the dust is very sticky, and lots of rocks and things, right? Here, oh yeah, so when you compare Olympus Mons, which is the large mountain on Mars, to Mount Everest, and that Ile de Hawaii, that is Mount Kilauea, or is it Mauna Kea? One of the two. So you can see Olympus Mons is way bigger. Here's a picture of it we've taken, right? And it looks like it has flow coming out of it, like it was maybe a volcano. All right, there doesn't seem to be any activity from it any time in the recent past, but it certainly looks like there's been flow coming off of there. Here are the moons, kind of oddly shaped, Deimos and Phobos. They do orbit around it like our moon goes around us. Here is those ideas of what might be going on with Mars. We're making these, we're drawing these conclusions based on some data, but I think somebody's wishful thinking here. We do see it in the sky. Sometimes if you look up, after you see Venus, you might see another star that looks kind of shiny in the sky. And if you look at it a little bit askance, in other words, a little bit away from it, you can tell it looks red. All right, sometimes if we look directly at it, you can't tell. But sometimes you'll see it and you say, oh, I feel like that's a red star. Well, it's probably Mars. Okay, it has what we think is a thin atmosphere, mostly carbon dioxide, some nitrogen, but a little bit of oxygen, right? So there we go. We want oxygen to be present. So the idea here is that one day we might get up there and be able to make more oxygen to put into the atmosphere. We'll see. Notice the gravity is quite a bit less on Mars, and that's because of its size, okay? The smaller something is, the less gravity it has. So it's quite a bit smaller than the Earth right there. Okay, so it's covered with red dust, and it's known as the red planet. You might have some blanks to fill in for that. Okay, so what about going to Mars? Have y'all heard about these grand plans to put people on Mars and to what they call it terraforming? Terraforming would be to make it like Earth by adding some atmosphere in there so we could grow plants and things like this. Okay, well, I've got a video to watch, and I'm not very, enthusiastic or otherwise optimistic about it. Let's watch.
From hostile deserts to lonely islands and the highest mountains, wherever there is space to expand into, humans do so. So it's hardly surprising that we're already making preparations to set foot on Mars and to create the first permanent colony outside of Earth, maybe even terraform another planet and turn it into a second blue home. But wait, before we can get to the nice future stuff, we first have to complete the second phase of colonization, creating a semi-permanent outpost to prepare the ground for a larger human presence. But doing so will be gruesome. Even for an expansionist species like us, Mars is extreme. At first glance, Mars seems familiar. Polar ice caps, large valleys, liquid water under its surface, and a day barely longer than Earth's. The ideal place for us to go. Unfortunately, Mars is actually a cold, radioactive desert where the ground is poisonous and breathing is impossible. Mars is awful. You almost certainly don't want to go there. The pioneers doing the hard work on Mars will have an intensely stressful life filled with incredibly challenging problems never encountered before. But there are plenty of people willing to do that work, and we have the technology to enable them to do it. For this video, we will assume there have been prior missions to Mars to scout out a good place for an outpost, store resources and equipment, and that there's already a moon base that serves as a hub for Mars missions. The first major challenge for our outpost is the fact that Mars is very energy poor. Because of its distance from the Sun, solar power is only 40% as effective as on Earth. But even this weakened sunlight is often obscured for days by enormous dust storms. Solar power alone will probably not be enough. Alternatives such as wind power and geothermal energy are also unfeasible, as there's hardly any atmosphere and Mars's interior is much too cold. Initially, nuclear technology might be the only option. Since Mars doesn't have easily accessible radioactive elements, the nuclear fuel needs to come from Earth along with the reactor. If we do set it up, it could power our small outpost for the first few years. Unfortunately, all that energy won't be very useful if we can't breathe. Mars's atmosphere is only 1% as dense as Earth's and mostly made up of CO2. So our habitats need to be pressurized and filled with an artificial atmosphere made of nitrogen and oxygen, which comes with more problems. Corners and flat walls are weak points, so the habitats will have rounded and smooth shapes to handle the stress of great pressure differences between the interior and exterior. The airlocks need to be very airtight and work perfectly every time. Without an extensive magnetosphere or a dense atmosphere, half of all radiation coming from space reaches the ground. A person on the surface would be subjected to 50 times the radiation that they would be on Earth. 3 years on the surface of Mars exceeds the radiation dose limits imposed on NASA astronauts for their entire career. This increases cancer risks significantly. To prevent that, we could shield our habitats with a thick layer of frozen CO2 that can be harvested directly from the atmosphere. Covering the dry ice with a meter of dirt would further increase the level of protection. Sadly, this means almost no windows. From the inside, most living spaces will be windowless tunnels. From the outside, they'll look like burial mounds. All of this would still not hold back all the radiation, but reduce it just enough to be survivable for long periods of time. It won't, however, protect anyone who ventures outside. So remote-controlled robots will be used for routine work on the surface while our crew stays inside. Staying inside is a good idea for another reason: Mars dust. It's much finer than dust on Earth, so it could find its way into the gears or electronics of our machines. Because it's also very dry, it's electrostatically charged, sticking to everything, like spacesuits. It will be impossible to avoid carrying lots of Mars dust into our habitat and into the lungs of our crew. To make this even worse, Mars's soil is filled with very toxic perchlorate salts. Constant exposure could be deadly. This problem can still be overcome, though. Spacesuits, for example, could be made in a way that they never truly enter the base, but stay attached to the outside of the habitats. Okay, great. Now we've safely isolated humans in terms of energy and air, and protected them from cancer, we just need to feed them. Water is easy to come by if a settlement is positioned near the Martian poles with their thick layers of ice. Growing food is a different kind of challenge, though. Mars's soils are alkaline and lack the vital nitrogen compounds that plants need to grow. Before we can grow anything, we will have to decontaminate the soil, which is difficult and expensive. Then the soil can be fertilized using recycled biological waste. All of this will take a lot of time and is very energy intensive. So we might use aquaponics to raise fish and plants together, making the astronauts' diets more varied and tasty at the same time. This will be an important psychological boost for our overworked crew. All of these things don't solve one fundamental problem, though. Mars has only 38% of Earth's surface gravity, which could cause muscle wasting, bone loss, and cardiovascular problems. While this might be solved in the future by setting up rotating living spaces, for now our crew has to live with low gravity and exercise a lot to slow the degradation down. The crews will probably have to rotate every few years. After being stuck indoors in tight spaces without windows, with the same people, performing the same routines day in, day out, with little contact from the outside world, and a lot to worry about. Like Antarctic scientists or submarine staff, they will undergo intense psychological screening to make sure they're mentally resilient enough to handle this lifestyle for several years. Establishing the first real infrastructure on Mars will be extremely taxing work that only a group of very determined and competent people can do. Luckily, we have enough of these on Earth. And there you have it, a small Mars base that will survive for at least a few decades, as long as it's getting a constant supply of resources, parts, nuclear fuel, and crews from Earth. Unfortunately, Mars and Earth are separated by millions of kilometers and orbital periods that leave only a narrow travel window every 2 years. If there's an emergency in the colony, Earth wouldn't be able to help until the next travel window opens. Helpers may arrive on a planet filled with corpses. Settling Mars will be the toughest challenge we have ever faced. It will be gruesome work to establish the infrastructure we need. But we're stubborn, and we like extreme challenges. If we push through phase 2 of colonization, anything is possible. Cities illuminating the dark Martian night, a hub for travel between the planets, industries setting foot in orbit, terraforming, a true multi-planetary future. Going to Mars is hard, but worth it. And if we're lucky, we might be around long enough to see it happening and cheer on the people who take on these challenges for the benefit of us all.
All right. So you can see why I'm not very optimistic about that. Boy, howdy, there's a lot of obstacles to overcome to do that. My gracious goodness. Also, I want to tell you about the asteroid belt. It turns out that, look at the sun. We have the sun, we have Mercury, Venus, Earth, Mars. Between Mars and Jupiter, there's this big old thing called the asteroid belt. It's only on a flat plane, almost like there's a plate, if you will, placed there. So if we're going to fly outside of Mars, we can fly over or under the asteroid belt, but not through it. Because guess what it is? Asteroids. We think what happened is there might have been a planet in there, and the gravity of Jupiter might have caused it to explode, and you can see that Jupiter also has some asteroids following it around as well. And we believe that some of those have been turned into moons that orbit around Jupiter. So we'll see next week about Jupiter and its 60 plus moons that go around it that probably have something to do with that asteroid belt. So it's good to remember that we have Mercury, Venus, Earth, Mars, asteroid belt, Jupiter, Saturn, Uranus, Neptune, then Pluto. All right. So 2 weeks from today, y'all, is our project due date. Okay, so this is a very simple project. You can see here, somebody just used cardboard to show that the Earth with the moon and how the moon can get between the sun and the Earth and cause an eclipse. And if you go on the other side, you can show that. So I know at least one of you was interested in talking about the eclipses due to the moon. So you could do something kind of like this. You can see it's not hugely elaborate. It doesn't have to be. I would, if I were you, make that sun bigger because it's so much bigger than that, right? Just to have it a little more accurate that way. Let's see if another, here we go. Somebody put a solar system model together here. What they did was they took those styrofoam balls, probably got them at Hobby Lobby, and cut them in half, and they're glued against a board. So there we have a half circle for the sun, a half circle for Mercury, Venus, Earth, Mars. Notice there's a little blurb talking about them right there, a little card with a little information. Notice also between Mars and Jupiter, that asteroid belt, there it is. Some rocks are glued there. And then they had the opportunity to do art with the colors of the planets. Here we see Jupiter, Saturn, Uranus, Neptune right there. All right, so that's a nice solar system model. You could do the whole solar system. Here's somebody did it with art, right? So here's painting. And they're just being very artistic. You can see the different planets around there. So if you're real artistic and you want to try it this way, these aren't in the proper order, but it's still very pretty. And your report would be about the entire system, the entire solar system. Now this, you can buy this ready to go at Hobby Lobby, and it'll have all the parts. I don't believe they're colored though. I think you have to paint them, I believe, unless some come with colors like that. But they have the little sticks and everything, and you can make the little model like this. So if you want to spend a little money on a model, you can do that. Also, Hobby Lobby has other models as well. For instance, if you wanted to do a model of the moon or a model of just one of the planets, you probably could find something there. This person decided to make a necklace that showed, so we have the sun to the left there, then Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and I guess they have Pluto on there. Yeah, so that's kind of fun, right? You would also be giving a report about the whole solar system. Here's somebody did the whole solar system using a cake. So it's always fun to have, food, right? Food in our project day so we could share with other people. Yeah. So that is beautiful. It seems to me like that dark icing on there might make our teeth blue. All right. So what we would have been doing today, y'all, would we, and some of you have already done this, but it's still a lot of fun. We were going to make some craters by dropping some marbles down onto some clay. And then I have these blow up inflatable planets. We could have blown those up and shown those, and I'll bring all those next week. But our big thing would be to make our moon phases. So we have our 8 phases of the moon. I would have asked you to remember these. You can see we're going to do it in 4, kind of like this. So even though there's 8, we would just do the 4, and we'll do it with our Oreos. Okay, so I have Oreos, double stuff, and you would start with the full moon, and then you would take away part of that inner part, and then a little more and a little more, and it would show those phases. It's a lot of fun to do that project. And then, of course, if you can, you get to eat the Oreo afterwards. Yeah. All right. So that's what we would have done. Apparently, there's a study guide here, and you can try to answer those questions if you like. I can put the answers up here. Planet that's the smallest is Mercury. The planet that's covered with clouds is Venus. Now, it says here this is on page 151. That page number may be incorrect, but this information is still correct, and it's good for studying because in a couple weeks when you do your project, we will also have a quiz. Which planet is the only one with liquid water and life-giving atmosphere? Easy, that's the Earth. Oh, it's not there. It's Earth, we know that. Which planet is closest to the sun? Mercury. Which planet is known as the red planet? Mars. Which planet is the hottest? Venus. Objects in the sky have patterns of motion. The path of a planet around the sun is called an orbit. Night and day are caused by the rotation of the Earth, you know. The sun appears to move across the sky from east to west. And the sun is a medium-sized star. And the sun has the most mass in our solar system. I wonder if Earth, no, it never got Earth up on the answer to that one question. Okay, gang, well, I hope you enjoy this. And I will see you hopefully next week. I'm feeling okay. I just didn't want to possibly give this cough to any of you. All right, have a great week and see you soon. Bye.